All right, I want to start off by going back to what we were talking about at the end of class on Wednesday, where I was trying to describe how you could take an object of a derived class. So we have our checking account class, and then we have the rewards account class that derives from that. And I was saying that you can take an object like Tom's rewards account here that's of this derived account class and actually put it into an array list that holds objects of the base class type. So we're putting like this line of code right here. We're adding this Tom's rewards account object into this list that's defined right up there that says it's supposed to hold checking accounts. So actually a different type of class. And that's what I started to introduce last time and started getting into the details of why you can do that, why you can assign one type of object to another type of variable. And that's where I got confused at the end as I started listing all the options on the board. So I want to go back to that and I want to describe why that makes sense. And as I draw a little diagram where we get back into this idea of looking at things in memory and looking at reference variables, I hope that this will make a little more sense. And I also hope that this makes a little more sense now that you've actually done this a little bit in your lab where you were adding some objects of different types to an array list. So like we're doing here, I'm adding some checking accounts into my checking account array list, and I'm adding some rewards accounts into my checking account array list. And so you did a little bit of that in your lab with some pretty strong guidance, but hopefully this makes sense why you can do that now. So let me jump over to the thing that I was trying to get at last time, okay? And so I can do something like this that looks weird at first, but again, I hope to explain this well with a picture. So I can actually write a line of code like this, okay? It's equivalent to what I was just looking at with the sticking something to an array list. But I could actually say checking account, Ed's account. So this is a reference variable here. I'm going to go ahead and label this. You have to remember what that means from our previous discussions. A reference in Java, all variables that hold an object actually hold a reference to that object, which is kind of a pointer to the location in memory. So this reference variable is a checking account, can actually be assigned to refer to an object from a derived class. So in this case, a rewards account object. So what we're doing here is we're taking an object over here. This is creating an object. That's what new rewards account does. An object of a derived class can be assigned to a reference variable of a base class. And again, at first that looks weird because you've always seen, you say rewards account, Ed's account equals new rewards account, or these two things always match. But there's a reason why this makes sense to be able to do something like this, and it's for the case like we were just looking at with the array list, where you can put multiple types of objects in an array list that contains one type of reference variable. So let me show you why this makes sense. So let's draw what actually happens in memory when we write this code. And this is where we have to go back to this concept. Let's see if I can zoom out a little bit here. This concept where we have two areas of memory where we can place things. Okay, we have the normal area of memory that happens to be called the stack, where we store all of our normal things. So if I'm going to write one more line of code up here, int foo equals 5. As we've said many times, all that would do is basically create slot in memory, or it would fill in a slot in memory. So memory looks like this. Create a little, pretty much label this as foo and put the value 5 in here. And then what happens when we come to a line like this, we've said, is that we now create a variable called Ed's account. And what ends up happening in a case like this where we're dealing with objects is we actually put the object itself in a different place in memory. So again, you could think of memory going as just one big one-dimensional stack here. Okay, but somewhere else in memory. If you drew it all vertical, it would be somewhere up here. I'm just, again, going to draw it over here to the side because I don't want to keep going up. And so we've got some memory over here. We've got a bunch of slots of memory that are continuing on. And we'll give them some addresses to reinforce this point again. So let's just say that this is address 502, 503, 504, etc. Right? And maybe over here we'll say this is 115, 116, 117, 118, etc. Right? So it's just all memory slots have an address. Okay, and so we've got some other area of memory here that we can put this rewards account object in. Now I'm not passing in all the parameters, although I probably should do that. Maybe I'll even do that here. So we had said that you could actually pass in a name in our latest version of this. So we know that a rewards account ends up having 4 variables that it's storing, right? An object of that type stores 4 variables. If we go back to our code, we'll look at our rewards account. A rewards account has points and monthly fee, and it also has the 2 variables that it inherits from checking account, which are account, well, I guess we have 5, account ID, balance, and we added name as the 5th one. So we actually have 5 variables for a rewards account. A checking account has 3, and a rewards account has 5 because it inherits 3. So we actually end up, if we went back to our diagram over here, we'll just put it somewhere in 5 slots, starting here. So we've got an account ID, we've got a balance, we've got an owner name, we have a number of points, and we have a monthly fee. Okay, and so this object is getting created here to represent this particular rewards account, and it would have an account ID, which would look something like this. You can look back at the code to see how that's created if you want. It would start with a balance of 0. It would have an owner name of Ed that was passed in. It would start with points of 100 because that's how the constructor initializes that, and we said the constructor initializes the monthly fee to 5. So that entire chunk of memory there represents one rewards account object. And what we end up with over here, if you remember from our discussion previously about reference variables, is essentially this ends up just referring to where that object is located in memory. And so it would end up with something like this. Address 502 is what actually goes into this location where the eds account variable, reference variable, is being stored. And again, the reason it's called a reference variable is it's not actually storing all the data right here. It's referring to, it has a reference to the location where, whoops, I'm sorry, I did that again. I've done that twice. Should have drawn that to 503 here. There we go. Okay. And so it's referring to the location where all of the data is actually stored for that object. So that's a little refresher of what actually happens when you write a line of code like this. So now we're going to talk about how this makes sense that this reference variable, that's a checking account reference variable, can refer to this type of actual object over here in the heap.